Well, we've been thinking about similar figures, but now let's think about similar transformations. A similarity transformation is a map that actually takes one figure to another figure with the property that those two figures are similar, which means you put them on a copy machine, you set the right percentage to increase or decrease, and you can make one totally align with the other. Let's take a look at some examples where we're going to see how to put together similar figures via similarity transformations. Here we go. Okay, so let's identify properties of similar figures. So figure ABCD maps to figure EFGH by a similarity transformation. And I'm going to stop right there because notice we're not given any figures at all. So we might just want to try to draw some in just for our own sake. Now, we don't know what these things look like, but since we're given that language, what I know is I'm going to have obviously a four-sided figure, and it doesn't have to be a rectangle. Could be that. And I'm told that it's A, B, C, D. So I start at A and I just go right around. And I'm told that that's going to be mapped to figure EFGH by a similarity transformation. That means that what we get on the outside here, the output, is going to be similar to this. So it could be bigger, it could be smaller, it could be the same size, we don't know. I'll make it bigger just for fun. And I'll try to draw it in a way that kind of looks like that. If you don't get it quite right, that's okay. But you can see that roughly speaking, these are going to be similar. Now, here's the important thing. We're told that the letters are E, F, G, H, and those are going to get mapped and hit on by A, B, C, D. That means that the A person here has to be the E person here. And now I just follow the same suit that I followed before. So E, F, G, H. So it's very important that these are corresponding. So now I can see that B corresponds to F, C gets mapped to G, D gets mapped to H, and so forth. Okay, so the fact that the letters come in a particular order is very important when we're thinking about these transformations. Okay, all that was just set up. Now, what was the actual question? Well, the actual challenge is to write a proportion that contains AB and FG. And then let's see if we can list any angles that must be congruent to angle D or congruent to angle G. All right, so what do I want? I want a proportion that contains the length AB. Now, where's that? That's over here. Maybe I should just mark that, highlight that. And FG. Now, FG is way over here. Well, so let me just remind you of properties of similar figures. If we have similar figures, then we know corresponding angles of similar figures are congruent, and corresponding sides of similar figures are proportional. And then here's the little example that we've been thinking about, which if I know that this triangle is similar to this triangle, then I know the corresponding angles are congruent, which means they have the same measure. And more importantly, if I take, for example, AB, and take a ratio of AB to the corresponding XY, then that will equal BC, and then its ratio with the corresponding part here. So what this tells me, if I want to get a ratio that contains these two people, what I might want to do is realize that, well, this side is proportionate to this side, and this length is proportional to that length, and so that way that actually gives me the appropriate ratio. If I look at this to that, that will equal this to that. And so what I notice is that the line segment AB and the line segment EF are corresponding sides, and similarly, BC and FG are corresponding sides, and therefore I see that this is to that as this is to that. Namely, I can now report that AB is to EF, so that ratio of lengths must equal BC is to FG, which is the ratio BC-FG. And there's the AB, and there's the FG, and notice that now they occur actually in a proportion. Now, the other part of this question was to list any angles that must be congruent to angle D. So let's see where angle D is. Well, angle D is this right here. And so what's the corresponding angle here? Well, it's H. And we know that since these are similar figures, the angles must be congruent. And so therefore I see that D and H are corresponding angles, which means in fact they are congruent. And what about an angle that must be congruent to angle G? Well, angle G is way up here. And you can see the way I drew my figure, that shows me that that corresponds to C. Notice that's why the orders of the letters are really important here to make this all fit. And so therefore I see that C and G are corresponding angles, which means that those are in fact congruent. And so there we have it. We've answered this question. Let's take a look at another one and see that in fact we can do this in a variety of different ways. Here we go. So, in this question, we have figure LMNOP maps to figure VWXYZ by a similarity transformation. Now, that's a lot of letters. It's almost like an alphabet soup. So again, I'm just going to draw a little picture to help me get a sense of what's going on. So this has, in fact, this is a five-sided figure. So we can draw any five-sided figure you want. 1, 2, 3, 4, 5. It could be that, for example. And now I'm going to label it L, M, N, O, P. And then that's going to actually map to another figure by a similarity transformation. So it means that this is going to be similar to that. I'll make this one a little smaller, if I can. There we go. And these are supposed to be similar, but it's very important that since this figure started with L and our other figure, it starts with a V, that L and V are going to correspond. And that gives me the recipe. Now I go around the same way I did before, and that will give me all the corresponding vertices. And so I'm told this is a similarity transformation, which what that means, of course, is that this figure and that figure, they're actually similar, which means that corresponding angles are congruent and corresponding sides are, in fact, proportional. Okay, so now what we want to do is we want to write a proportion that contains WX. So WX, where's that? WX is right here. And I want to link that to the length LP, and LP is over here. And then I want us to see any angles that must be congruent to angle W or congruent to angle N. Well, so there's lots of ways of thinking about this, by the way. There's not just one answer here. So one thing I could do is notice that line segment MN and WX are in fact corresponding sides, and similarly LP and VZ are corresponding sides. So I'm trying to find something that corresponds to this over here, something that corresponds to this over here, and once I've done that, then I know that I've actually now can look at a particular proportion. I could say that this MN is to this WX as LP is to VZ. And so we are going to write that right now live so you can see it, because I don't want any typos. The best way to make sure there's no typos is write it yourself. So MN is to WX. You see how I really am picking up the corresponding vertices, and that's going to be equal to the ratio between LP and VZ. Okay, now here's the important thing. Notice that I'm always going from this one to that one, this one to that one. See, the numerator on both of these comes from the first, and the denominator comes from the second. Now, you could have written this the other way if you wanted to. You could have had the numerators all be from the second and the denominators all be from the first. So there's lots of ways of writing this, but the important thing is once you commit to what's on the numerator, it's got to be the same corresponding piece from that, I'm sorry, the other side of the same figure. So we have top is from this, bottom is from that, and so forth. Okay, now what about angles? Well, we know that corresponding angles are going to be congruent. So what are the angles that must be congruent to angle W? First, we have to find angle W. That might not be so easy. There's so many here. Here it is right here. And the way that I've set this up, I've drawn this so I can see immediately that corresponds to M. And so I see that angle M and W are corresponding angles, which means that they are, in fact, congruent. And what about an angle that is congruent to N? Well, where in the world is N? Well, N is way over here. It's that sharp one. By the way, we don't know if it's really sharp. That's just the way I drew it, just to help me find that, in fact, it's going to correspond to the X. And so therefore I see that angle N and angle X are corresponding angles, which means that they are, in fact, congruent. There you have it. Well, you can see that similarity transformations are really just transformations that we've seen before, but we're given one extra piece of information about that transformation. Namely, we're told that the two figures, in fact, the pre-image and the image, are going to be similar, which means that corresponding angles are going to be congruent, and, of course, as always, corresponding sides are going to be proportional. Have fun looking at similar figures in your life. I'll see you soon.